Hello everyone, welcome to POC TV. As part of POC today, we're going to see about the Python Pandas chart visualization. The objective of this proof of concept is to understand more techniques for chart visualization in Python Pandas. In the last session, we have seen few plotting mechanisms. So in continuation to the same variable definitions, same graphs we have defined in the last session, this particular video will continue with more techniques. Today we are going to see about loading some required libraries, some terminologies, bar plots, single, bar plots multiple, bar plots stacked, and bar plots horizontal, and then summary. These initial library loadings and then the terminologies, all we have seen in the past, have added one additional terminology here. It's ILOC, it's integer location function. This is used to select the rows and columns by integer index position. So we will be using this in our plotting mechanisms. So these series and data frame, X and Y plotting we have seen in the past video. So in continuation to that, I am using the same variables which I have used in the above plotting mechanisms. So I'm continuing with the same. To start with the bar plots, simple one, we are plotting a figure of function and then use the above variable which we have used datf, integer location of, I'm using the fifth location. So plot of function in the kind I'm giving a bar. So there are many kinds you can provide. I'm starting with a very simple bar plotting. So I'm exiting this. If I run this, you will see the bar plot is plotted here. So you can see the value because I have given 5, 0, 1, 2, 3, 4. I've taken the 4 positions, 0 to 4. Whatever I have used in the earlier graphs, you will probably see here BOGR for blue, orange, green, and red. So the same is being plotted here. You can see blue, orange, green, and red. That is for the simple one. And then if I have to do another bar plot with the axis line in it, so I'm plotting a figure of function and then using the data variable from above, integer location of, I'm using 100 here, plot dot bar of. Also, I'm adding plot axis line here, and I'm saying the axis line should start from 0, color equal to maroon. So I'm exiting this paragraph, loading this. So you can see the axis line is drawn here, which is maroon in color. You can see the other bar graphs difference. Now I am doing a bar plot for multiple. I'm using a dat f2, whatever I have used before, and I'm assigning this particular data frame with a random from a numpy function and passing a 10,4 cross matrix, and then I'm using the same columns I have used above for blue, orange, green, and red. I'm using the same variable datf2 dot plot bar of. So you can see each color like blue, orange, green, and red using this random number combination has plotted 4 different bar plots for each one. I'm doing a bar plot stack. I'm using the same variable datf2 dot plot bar of stacked equal to true. I'm using an extra value inside the function So where you can see stacked equal to true. If I play this, you can see the same plotting has happened in a stacked fashion. In this graph, you can see each color, these random values, it's segregated separately, blue, orange, and green, red. But here you can see the same is being stacked one on one top of the other. So if I say false here, you pretty much see the same one what you saw above, because it's not stacked. So obviously it will be separated. So making this true back. So I'll see the difference here, stacked fashion. Now I'm doing a bar plot horizontal. I'm passing the same variable that f2 that plot bar. I'm adding a h, which is denotes the horizontal function, and I'm saying stacked equal to true. Exiting this, executing it, you can see the stacked same as this one, but it's in a horizontal bar graph instead of a vertical one. So if I say stacked equal to false here, you will see the same separated, four separated colors are in a horizontal fashion. So you may not be able to see very clearly. So it's better to have true here. So you have this in a horizontal way, looks very legible and readable. For representing a huge data volumes you have, these graphs are very useful. So you can frame your own data frames and pass, a number of values inside, or big tables, and then plot the graph with these functions to be very useful to represent to the top management. Most of the people in the top management, they'll be expecting some graphical representation of that data rather than boring numbers in a huge tables nobody understands. So if you represent the same huge tables in the form of various plotting mechanisms, you can represent it very very clearly in a one shot. People can easily understand. Okay, so the blue area, orange area, green area, red area is being stacked like this, and according to a various department or various categories, you can say, okay, this is on top and this is extremely low. Those kind of representation can say, okay, this particular area 4 requires more attention, so that this can grow a little bit higher. you know think about the same graph if you are showing in a tabular column fashion, like a spreadsheet with hundreds of values in it. You spend hours in explaining, but it may not reach everybody. So these graphs are very useful in terms of explaining people very easily. So pictorial representation always plays a vital role in terms of presentation. Numbers are numbers, but you cannot read them easily. But this is very useful. So to summarize, we have loaded some required libraries and we have seen some terminologies, plotted bar plots single and bar plots multiple. We did bar plots stacked. We did bar plots horizontal. I hope you enjoyed today's session. Thank you.